Alright everybody, this is Mr. Kestel. This is the third video in this video series. This video is talking about different types of circuits. So here we go. Okay, so now we've learned a lot about electricity, but what do we actually do with it? How do we actually use it? Well, to explain that, we're going to talk about electrical circuits. Okay, so sorry about the spelling error. Now, electrical circuits. What the heck is that? What are we talking about? Well, a circuit is a closed path. Sometimes it's called a loop or a branch, which electrons can flow through. So to illustrate this, I've got a little program here, and we're going to take use a couple tools here. So I've got a battery, I've got a wire, some wire, and I got a light bulb. And notice that the light bulb is not turned on yet. Nothing's happened here. So what do I have to do to turn the light bulb on? Well, I have to have a complete loop that the electrons can go around. So the electrons go from the battery up to the light bulb, back around, and back to the battery. If that loop is not closed, if it's called an open circuit, then nothing will flow through there. One thing that we use in everyday life is called a switch. And a switch is something that we can open and close a circuit with. So we can open and close a circuit with a switch. Okay, so I'm going to take that switch out there for a second. So if you look at this light bulb, there is voltage coming from the battery. A battery is able to produce voltage. That's what a battery does. And so it allows, because it has a voltage there, there's a difference from the negative end and the positive end. Then when we hook it up into a loop, the electrons will flow from one side of the battery to the other side of the battery. So this is just one loop here. And so that's a special kind of circuit. We have two different types of circuits. So we call this a series circuit. This is a circuit with only one loop. Well, I'll say one path. Again, sometimes it's called a loop, sometimes it's called a branch, which electrons can flow through. So, what can we do with this? Well, if we wanted to, we could add another light bulb and another battery, or another light bulb into this, which I actually already did. And this battery now is powering, or giving electricity for both of these light bulbs. And I could do 3, and I could do 4. And I want you to notice here what's happening. Look at these yellow lines here. That's supposed to represent how bright the light bulb is. When I add in a series circuit, if I add another light bulb, then the brightness of the light bulb goes down. And you can tell that even more when I add more light bulbs. Look at how little these lines are as compared to the first one by itself. So that's an important limitation of a series circuit. So we could say in a series circuit, adding more light bulbs will make the brightness go down for all all the bulbs. Okay? And, so the same thing would apply if you had pencil sharpeners. If you had 3 pencil sharpeners hooked up in series, so instead of light bulbs, you had pencil sharpeners, well, then each pencil sharpener the electric pencil sharpener would not work as well because if they were all hooked up in series. Another thing to know about series is that if you disconnect one light bulb, you'll disconnect all of them. So if you notice, let's see if I can zoom in here. I don't think I can. Okay, so if you remember back to that picture of the light bulb that I had pulled up earlier, inside the light bulb was a little squiggly piece of metal. And that's not the exact picture, but it'll work. And so if that light bulb, if the little wire in there gets broken, or if we unscrewed a light bulb, which this program unfortunately doesn't let you do, then all of a sudden no electricity would flow. And if you've ever used a string of lights, like on a Christmas tree or decorating in the wintertime, and the little light, if a little light bulb goes out, then all of the lights will go out. That's because if you disconnect one, then none of the electricity, you've broken the loop. So over here with all 4 of these light bulbs, they depend on the whole loop being connected. So also in a series circuit, we'll say that turning off one bulb will turn off all the bulbs. Okay, so I kind of gave you a little preview of it, but there's a different type of circuit. This series circuit only has one path. Well, what if we had multiple paths? We call that a parallel circuit. So this is a circuit with 2 or more paths. And again, sometimes they call these loops, and sometimes they call these branches. Okay? Which electrons can flow through. And remember, when we talk about electrons flowing through, we just mean current. So, let's look. I already built one here. And this is a parallel circuit. So it's called parallel because you've got 2, you can kind of see here, there's a line going across the top here and going across the middle here, which are kind of like 2 parallel lines. So that's what they're talking about. So in parallel circuits, you can disconnect one light bulb and it doesn't affect another one. And also, both light bulbs have a lot of brightness. In fact, they have the same brightness as if there was only one light bulb in the loop. So parallel circuits are super handy that way. And this is what we use to power our houses. So used to provide electricity to houses. And this sort of makes sense because oh, I didn't want to do that. Here we go. Okay. So I'm going to cut this little thing here and I'm going to add a switch. So we'll pretend like these are light bulbs in 2 different rooms. So, and I'm going to add a switch up here also. There we go. Okay, so in your house or apartment or wherever you live at school, if we turn off one bulb, it does not turn off the electricity for the other. Okay, so they're independent of each other. Likewise, if your house or apartment or wherever was in series, let's say instead of a light bulb here, we have a TV. So if you turn the TV off, that means if it was all in series, you turn one thing off, everything's going to turn off. Well, that's not very handy. So in the real world, in our houses and buildings, schools, everything is in parallel so that if you turn one thing off, it doesn't turn everything off. Okay, now that we know about circuits, I also wanted to go back and kind of talk about insulators and conductors. So on the left-hand side here, there's lots of different things that could be an insulator or it could be a conductor. So a wire, we can already see, is a conductor because it lets the electrons flow through it. But let's try some other stuff. For instance, let's try a dollar bill. Well, a dollar bill is an insulator. It's not made of metal. It doesn't allow electricity to pass through. Probably already figured that out. Eraser, same idea. Doesn't allow the electricity to pass through. There's lots of others here we could try. If you tried your hand, generally an insulator, you could actually force electricity through your hand, but you have to have a whole bunch of voltage. And so actually maybe I can change the voltage here. No, still not going to work. Okay, at least in this example. So just wanted to show that. Okay, there's another thing that's used in houses and lots of electrical devices, and that's called a fuse, which I found over here on the left-hand side. So a fuse is a special sort of device that will melt or break the current break the circuit if the current in it becomes too high. Let me write that down here. So a fuse will melt if the current in a circuit gets too high. So this is used because in lots of different ways to protect your electrical devices. So if you have a circuit breaker, if you have a fuse, then let's say a strike of lightning happens, and so a whole bunch of electricity is trying to pass through your house. Well, something like a fuse will break, and so then your electrical devices don't get fried. Because if there's no loop, then the electricity can't pass through it. So we can test that out here. You noticed before that the electricity was passing through fine, but now if I add a wire here and connect this back up, this fuse broke, and that protected my light bulbs because there's no electricity passing through it. Alright, well that just about does it for this video. The next video and this last video that we'll have will be about power and batteries. So I hope you had a wonderful day full of laughter and joy, and I'll see you next time.